we have established routine by which you can get factorization of a quadratic expression. Now, today we want to see how do we know that this quadratic expression can be easily factorized into simple forms. You need this so that you will not waste your time and energy in solving mathematical problems. Now, let's look at this, for example. This is 2x raised to the power 2 plus 5x minus 3. There are certain routines we can use to find the factor of this. But before you use it, is it possible for you to know whether you can easily factorize this using those simple methods? Yes, it's possible. And that's what you want to do. Now, look at this. This is x raised to the power 2. And this is the coefficient of x raised to the power 2. Let's take that as a. A, the coefficient of x raised to the power 2, which is equal to plus 2 or 2. Now, let's look at the second one. This 5x, the coefficient of x here is plus 5. So let's put that as b. Now, this one is the constant. The constant here is minus 3. Let's take that one as c. So how do you test whether you can easily factorize this? Use this formula. So you use this formula, and if after using the formula you get perfect square, then you can easily factorize that. Let's slot in this here. You have b squared, which is 5 squared. Then you have your 4. Your a is 2. And your c is minus 3. 5 squared is 25. Now, but don't forget this minus times minus, which is plus. 4 times 2 is 8. 8 times 3 is 24. Now, if you add this together, it will give you 49. So 49 is a perfect square because 7 squared is 7 times 7, which is equal to 49. Therefore, this one you can easily factorize it. We have established the fact that this can be factorized into simple factors. Now, let's now try to follow the routine and do the factorization. You multiply this by this. 2 times 3 is 6. So you have 6s squared. Now, what are the two factors of 6x squared that can produce 5x? Now, you can have 6x multiplied by x. That is 6x squared. If you say 6x minus x, it will give you 5x. So we have this. Now, you now replace this here. You have 2x squared plus, now instead of writing 5x, you write 6x, then minus x. Now, very simple. Then what is common? 2 is common, and then x is common. So put that one out here. 2x squared divided by 2x, you have x, plus here 6x divided by 2x, you have 3. Then the next thing is, you now put plus, okay, this is minus, minus, this is x divided by, okay, what is common is 1. So 1 is common to this. So you have minus 1. X divided by 1 is x. Now here, you don't put minus. If you put minus here, it means you have altered this. Because minus times minus is plus. So you put minus here. So minus times minus is plus. If you put minus here. So you put plus here. So as to retain this. Minus times plus is minus. 3 divided by 1, you have 3. So this is 2x minus 1. Then you have x plus 3. So these are two simple factors. So the product of the two will give you this. So let's look at another example. Before we waste our time trying to factorize this algebraic expression or quadratic expression, we want to find out, can we factorize this into two simple factors? And how can we know that? Now, what's the coefficient of x raised to power 2? That is plus 3. What's the coefficient of x, which is b? That's minus 4. What is the constant here? The constant, which is c, is 5. Now, let's now use this. Let's use this. Our b is minus 4. Our a is 3. Our c is 5. Now, minus 4 squared is 16. Minus 4 multiplied by 3 is 12. 12 multiplied by 5 is 60. Now, 16 minus 60. What we have is minus 60 minus 16, which is from 60 take away 16, 4, that's 44, minus 44. You now ask yourself, this is minus 44. Is this a perfect square? No, it's not a perfect square. For a perfect square, you cannot get minus 44. Perfect square like 1, 4, 9, 25, 36, and so on and so forth. So this one, you cannot factorize it following the routine that we have started with from the beginning. So once you know that, you can know what to do next. So I want you to try this. I want you to find out whether these ones can be easily factorized into two factors or product of two factors.